In this video, we're going to work a problem with the stoichiometry involving gases. Okay, so here is the idea. We're going to run a reaction in which we're going to mix magnesium, which is a solid, with HCl, which is in aqueous solution, a solution of hydrochloric acid. And then this reaction involves a gas, which is hydrogen, okay, with the formation of magnesium chloride. Okay, so magnesium chloride would be a salt in solution, and then that involves hydrogen gas. All right, to balance the reaction completely, we need a 2 right there. Right, so the idea is as follows. We're going to mix 1 gram of the solid magnesium with 50 mL of a solution of HCl of a given molar concentration, which in this case is going to be equal to 1 molar. Okay, so 1.00 molar. It's a very simple experiment that you can do, right? So you have here a flask. Here you put the HCl, which will be an aqueous solution, 50 mL, 1 molar. And then what you do is just pour the magnesium, which will be a solid. When the reaction takes place, hydrogen will be evolved. And you can actually test that because you can put here a balloon, and the balloon should inflate with H2 as H2 is produced from the reaction and gets there. And that balloon should inflate. And that's a demo that you can actually do relatively easily. All right, so the question is that we're going to be asking is, if we carry out this experiment at a temperature of 25 Celsius and a pressure of 1 atmosphere, what would be the volume of H2 that is evolved, right? So how much H2 will have in that balloon. Right, so we actually know from this statement whether the reaction, the reagents are mixed in the correct stoichiometric amounts, or whether there's one in excess and we have a limiting reagent, right? So this is going to be then a problem of limiting reagents, in which we're simply going to calculate the yield of H2 according to whether each of the 2 reagents is limiting. And then from the moles of hydrogen that we get, then we should be able to calculate the volume using the ideal gas equation. All right, so let's get started with the stoichiometric problem. Let's assume that magnesium is limiting. If magnesium is limiting, then the moles of H2 that you would get would be as follows. We have 1 gram of magnesium, okay, and we know that for every mole of magnesium, we'll have a molar mass, the molar mass of magnesium, okay, which in this case is 24.305 grams of magnesium. Okay, so divide the mass over the molar mass. This is going to give me the moles of magnesium, and now I use stoichiometry to figure out how many moles of H2 I have. Notice that the stoichiometric relationship is 1 mole of H2 for every mole of magnesium. Right, and when you calculate that, this number happens to be 0.0411 mole of hydrogen. So that would be the yield if magnesium was limited. Well, but we don't know if that's limited or not. It could also be that HCl is limited. Right, so let's do the stoichiometric calculation with HCl. Now the number of moles is going to be calculated directly. We can calculate the number of moles with the molar concentration and the volume. Okay, notice that that molar concentration means that you have 1.00 mole of HCl for every 1 liter with 1 liter of HCl. And the volume that we have is 50 mL, which is the same thing as 0.0500 liters of HCl. And now we use stoichiometry to figure out what the number of moles of H2 would be. All right, so that would be 1 mole of H2 over 2 moles, or for each 2 moles of HCl. Right, notice that all of the hydrogen comes from HCl. HCl only has 1 hydrogen atom, so you need 2 molecules of HCl to be able to evolve a molecule of H2. Okay, notice also that this is a redox reaction, in which what we actually have is magnesium oxidized into magnesium 2+, and then hydrogen reducing from +1 to 0. Okay? All right, so when you do this, when you type this, okay, this is a fairly simple calculation. The output that you get out of this is 0.02 250 mole of H2. So obviously HCl is limiting, and then magnesium is in excess because the yield of hydrogen that you get from the stoichiometric calculation with HCl is lower than the one that you get with magnesium. Okay, so we're halfway done. We have calculated the number of moles that we're going to generate of hydrogen, which is this amount, and then our final calculation is the volume of hydrogen that you will get. Okay, but this can be obtained from the ideal gas equation of state. PV is equal to nRT because we have everything that we need except for the unknown, right? That's what we don't know, but the pressure is 1 atmosphere according to the statement, the temperature is 25 Celsius, and then the number of moles we just calculated. Okay, so here we're going to have that if we solve this equation for the volume, okay, the volume of hydrogen is going to be equal to the number of moles, RT, over the pressure. Right, so let's plug in here the values. 0.025 mole multiplied by 0.08206 atmosphere liter over mole Kelvin multiplied by the temperature in Kelvin, so 298.2 Kelvin, and then divided over the pressure, which is 1 atmosphere. Okay. Alright, when you type that in the calculator, this volume happens to be equal to 0.60612 liters, which is a fair amount. This is a little bit larger, slightly larger than the amount of volume that a 20-ounce bottle of Coke would hold. Okay, so that's how much hydrogen gas you're generating under these conditions. Okay? Alright, so this is a typical problem in gas stoichiometry in which we've been able to use limiting reagents to figure out the number of moles of a gas produced, and then use the ideal gas to figure out what the volume of that gas is.